Now let's look at an example of test of independence. Here we have an industry association for beer industry, and they want to test whether the choice of beer is independent of the gender of the customer. So they took a sample of 200 beer drinkers and then did a survey in that they asked whether they preferred which of the three beers. Okay, there is light beer, regular, and dark beer. And then the questionnaire also included whether the customer selected is male or female. So the test that we want to conduct is beer preference is independent of gender. That goes in the null. Remember, always independent always goes in the null, and not independent goes in the alternative. So then the sample of 200 turned out to be like this. So we have total 200, of which 90 were light beer drinkers, 77 regular, 33 dark, 132 for male, were male, 68 for female, and this was the individual breakdowns. Now with this sample, now we want to conduct the test. So let's go to the Excel file now. So now we have to define what the two variables are and what the hypothesis and what alpha level we're going to use. Okay, let's define the variables now. Okay. Choice of beer is the first variable, gender is the second variable, and independent is null, not independent is the alternative hypothesis, and 5% is the alpha value. Okay. So now here is the data given in the textbook. So we sum row wise, so that gives you the row total. Okay. And then we sum each column and you get the column total. Okay. Now remember, it doesn't matter how many columns or how many rows, this thing will work. You have to apply it consistently, and this is the grand total. That's our sample size. So sample size is that grand total. Okay. Now we'll compute the expected frequency. Okay, remember, row total times column total divided by the sample size is the same formula like we used in the previous example, and we need to use the absolute referencing very carefully. So for the first cell here, the first row, and the row total should always come from the column, so the dollar should go into for D and not for the row, and then that one. Okay, here the row specification must have a dollar sign, not the B, divided by the sample size. Well, we can use that cell or this cell, it doesn't matter. And here we should have dollar sign for both of them. Okay, so now remember, it can be non-integer. That doesn't, you need to keep the non-integer part as is. Okay, so now these are the expected frequencies, and if we sum, we copy the sum formulas from the previous table, it should be exactly same as that one, and here again the columns totals must also be exactly same, and all E sub I j values are greater than or equal to 5, which means the sample size is large enough. Now the chi-squared values are observed frequency minus expected frequency, and we have to square that and divided by the expected frequency. Now you copy that for the rest of the cells. Okay. Now let's put the border back. Okay. And when you sum the whole thing, that's your chi-squared calculated value. Okay, the number of rows, we'll use count A. Okay, now we're talking about number of rows. That's our N. And count A for columns, that's our number of columns M. The degrees of freedom is N minus 1. times m minus 1. That's the degrees of freedom. So the formula is given here. Okay. Now if you want to test using the chi-square table approach, we do chi-squared dot inv dot rt, and we use the alpha value and degrees of freedom, which is right there. Okay. So that gives us the chi-squared value, and we compare the calculated value with the table value, and if calculated value is larger than table value, then we reject, and in this case that is so. So we reject that those two variables are independent. So apparently there is a the preference for men and preference for women are different. Okay. Now we can use the p-value approach, which means that we have to use chi-squared dot dist dot rt, and we use the chi-squared calculated value and degrees of freedom. Okay, RT doesn't have you don't need the comma 1 at the end. If you just simply chi-squared dot dist, then we have to use RT. I mean, you have to use comma 1, sorry. So now, since p-value is less than alpha, we reject the null hypothesis. So we do have sufficient sample evidence to conclude that the preferences are not the same for the two genders, and the probability that our conclusion is wrong is 3.98%. So there you go, that's our interpretation.